Today I'll be presenting my course project for ipv6 class. This is in the winter of 2018. I want to explain ipv6 formatting and talk about ipv6 advantages for cloud services as my course project. The next generation of IPv protocol suites is IPv6. IPv4 is a 32-bit naming convention. We are running out of IPv4 addresses. We need the need for IPv6 it has 128 bits, which is 4 times larger than IPv4. That's 53.7 billion addresses per person on the planet. A total of 3.4 times 10 to 38 IPv6 addresses are available with the new convention. IPv6 is a hexadecimal address system, 1 through 9 and A through F. In the IPv6 address, there's 8 groups separated by a colon, 16 bits each, 4 bits at a time. Each is and 64-bit addresses for the street name, and the last 64 bits or 4 groups is the host ID. Here's some examples of IPv6 addresses. Here's the decimal, here's the hexadecimal, and here's the binary. Here's an example of just, I'll add one, so 0, that's 4, if you look off to the right a little bit, and then 0 and 1, that will equal to 5. And that's basically how the binary would be written for the different characters or numbers that IPv6 has available. So here's the 8 addresses. The first 4 is basically the street address, which is the street name on a network. Last 64 is the host ID. Last 4 here, the host ID. Where X is a 16-bit hexadecimal field. Case sensitives for hexadecimal, it's insensitive. You can have A, B, C, D, E, and F as capital or lowercase. The lead zeros are in the field is optional. Successful fields of zeros can be represented as double colon, only once per address though. Here's an example of an address. And it could be shortened here to this. See the 2 sets of zeros represented by the double colon, and only double colon can be used once. So here's the 0 representation of this part of the address, and you notice that the 0 is removed there as well because the zeros are optional. And most computer systems default to the shorter name after you enter in IPv6 address. Because of the internet, e-books, cable companies, automobiles, and all the different features they have on automobiles nowadays, we have a larger user internet population base, which is continuing to grow. And addressing, since there's so many addresses. And the larger address base adds more security to your systems. The simplified header, you have fixed header size in IPv6. And then there's extension headers, and each of those extension headers can have an option to add another header. So basically there's a large amount of information that can be stored. But there is a fixed header that is required for all IPv6 addresses. We need smooth transition. The idea seems to be like less transition all systems because they're dual stack, and where you can have ipv6 and ipv4 packages tunneled. There will be islands of ipv6 that need to be connected to ipv4 through tunneling. In our lifetimes, we see ipv4 because of the seamless transition of the tunneling mechanism we have available today. In the future, there will be islands of ipv4s, not islands of ipv6s, and the ipv6 will be the most prevalent IPv addresses. The security dramatically expanded for IPv6 is mandatory. According to recent statistics, more than 60% of businesses are using cloud IT solutions in some form. Both its cost saving and business agility are reflecting in the statistics that more than 80% of organizations that adopt cloud services saw a decrease in IT costs, along with improved IT services. Spending on cloud computing is projected to exceed, or it did exceed, $180 billion in 2015. IPv6 will become a critical component in facilitating rapid horizontal scaling of public cloud services, leading to eventual legacy protocol status for IPv4 and the higher cost of providing legacy protocol to customers. Meanwhile, organizations that are focused on IPv6 adaptation are recognizing additional themes that will likely impact their subsequent requirements and consumption of cloud services. Large cloud providers are running into scale constraints imposed by IPv4. They are also having consumer demand for IPv6 enabled virtual private clouds. Many organizations are aligning their clouds to IPv6. New cloud providers are more likely to see IPv6 in the marketplace. New cloud providers are more willing to use the architect of IPv6. New private cloud deployments can have IPv6 compliance requirements. More than 50% of mobile traffic is on IPv6, and as well as their apps. IPv6 will rely on many IPv6 operational practices evolving from clouds that are using all these systems. Here's a look at the public cloud. Among the 9 most popular public clouds, 1/3 of them claim to support IPv6. Of the services that don't support IPv6, they're facing some scrutiny about their IPv6 support. And then there's also private cloud platforms. Limited support for IPv6 in private cloud companies, as well as missing support for well-established public cloud platform, indicates that IPv6 in the cloud is clearly a work in progress. IPv6 initiatives in parallel with their cloud initiatives, they're developing these. Hopefully the two will be linked, and the evolution of IT services will continue. In conclusion, I'd like to thank my fellow students and teachers at the college for helping me learn more about information technology and IPv6. Thank you for your time.